Welcome. We are starting a new chapter, which is going to be all about graphing and functions. In this section, we're pretty much going to be just reviewing. Specifically, we'll review how to graph an equation in two variables, for example, y equals x squared. First of all, a solution to an equation in two variables. So what would a solution to something like y equals x squared look like? Well, it's an xy ordered pair that makes the equation. What do solutions do when you plug them into equations? Yeah, they make the equation true. So solving an equation is a search for truth. Now what's different here is before our solutions have been just numbers, right? A single number, like for example, if you're asked to solve, you don't necessarily need to write this down. I'm just kind of reminding you, if you're asked to solve, say, x plus 1 equals 2, you subtract 1 and you get x equals 1, and your solution set has a single number in it. Well, when we're solving equations with two variables, our solution sets wouldn't have single numbers in them, they'd have ordered pairs. Now, the thing about solving equations in two variables is that there are usually infinitely many of these xy solutions. So instead of trying to list them all in a solution set, so we're not going to try to do this because there would be infinitely many, xy pairs in there. So instead of doing that, what we'll do is make a picture of the solution set. This picture of the solutions is known as a graph of the equation. Okay, so for some reason we don't use the word solution set. Making the picture is called graphing the equation. So the problem instructions are going to say, graph the equation, or they might just say graph. They're not going to say solve the equation, even though that is what you're doing. You're really finding a solution set and making a picture of the solution set. But we call that, it's just the word that we use for that is graphing. Now, in order to graph a pair of numbers, so remember our solutions are xy pairs. In order to graph those xy pairs, we use a pair of number lines. Okay, in what's called the rectangular coordinate system. It's also, by the way, known as the Cartesian coordinate system after its inventor, the guy who's reputed to have invented it, René Descartes, who you may run into in non-math classes as well. So the story is that he was lying in bed looking up at his ceiling, which apparently was a tile ceiling, and he was watching flies crawl across it, okay? And so he came up with this way of describing the position of the fly. That's the story anyway. Okay, so just a little review of how the Cartesian or rectangular coordinate system works. Again, there's a pair of number lines. We've got the x number line and we've got the y number line. And to plot a point such as, say, we have our usual setup, okay, like we've been seeing all along on the number line. The vertical number line has positive numbers going up, negative numbers going down. And so to graph say 6, 4, you go above the 6 and across from the 4, and that's 6, 4. And by the way, that's why we call this pair, this XY pair, we call it an ordered pair, because if you change the order, that changes the dot, right? 4, 6 would be somewhere up here. That's a different dot than 6, 4. Okay, is that plausible the way I've done that? 4, 5, 6. Yeah, that's probably about right. Okay. So the order matters because it's a different dot. If you have the numbers in a different order, that's how the graphing works. I'm going over this extremely quickly, I freely admit, because I'm assuming that you're not only familiar with, but fairly comfortable with this from earlier classes. Some terminology: the 0, the spot that says 0 on both number lines is called the origin, just like it is when you have a single number line. Let's see, what else do I need to remind us of? Oh, these two number lines divide the paper or the coordinate system up into 4 areas that are called quadrants. This one is quadrant 1. This one is called quadrant 2. So 4 quadrants. We start with the one where the X's and the Y's are both positive, okay, because that's everyone's favorite quadrant. Call that quadrant 1. Then we go counterclockwise and number our quadrants. So we have quadrant 2, 3, and 4. And I'll just point out that in quadrant 2, the X's are negative. The Y's are still positive. In quadrant 3, if I make a dot here, like say that dot's at -1, -1. So notice the X's and the Y's are both negative. In quadrant 4, like say I plot a dot here, that's the point 1, -1. So the X is positive and the Y is negative. On the x-axis itself, the y values are negative, right? Because you're across from the 0 on the y-axis. On the y-axis, the x's are 0 because, if you make a dot on the y-axis, so for example, the coordinates here are 0, 2, because you're above the 0 on the x-axis. And then, so why did I say y is 0 on the x-axis? Well, let's take a dot on the x-axis. What are the coordinates of that point? 6, and I'm across from the 0 on the y, so 6, 0. Actually, the equation y equals 0 is an alternative way of saying you're talking about the x-axis, and the equation x equals 0 in this context should be interpreted as the y-axis. That's probably a good stopping point. So I'm going to stop there and we'll come back and do some actual solving graphing examples. So I'll see you then.